what's going on, give me some more information, please stop me. We do have a little more time, as I said, this afternoon than we had this morning, so we'll be able to chit-chat a little more. We had some good conversation back and forth this morning about installation and other things and design. It makes it go much better for you if we talk back and forth, and it certainly is helpful for me to know what you want to know. I can only guess at what you need to know unless you ask me questions. So ask me questions if you have something you want to know about, and we'll be able to do that.
Why don't we just take a second, get you mic'd up on the
Sure.
It's
killing me standing still.
Yeah, I've been with you for a day or two. I can imagine it is.
Sure, I got it. How's it sound? You got me? You'll get me when I get up here? All right. Oh, that's so much better. Now I can walk around. That's good. Much more relaxed. Anyway, so we'll try to cover those topics. Again, like I said, if you have a question, please stop me. If you want to know more about something, I'd a whole lot rather cover what you want to know than what I want to say today. I want to make sure we cover your issues, not what I think your issues might be. I think it's important, and I will say this from a concrete pipe industry standpoint, we very much support municipalities, DOTs, engineers requiring post-installation inspection, requiring stringent post-installation inspection. We think that's good for all of us. It makes sure that we are paying attention to what we're doing from a production standpoint, from a shipping standpoint. It will help your installations, I think, a little bit, because everybody, from the inspector to the installer, all up and down the line, they pay a little bit more attention to what they're doing if they know it's going to be stringently inspected. I think that's common sense and would be done almost all the time. So I think we get good installations and it can help. So it can be a safety issue. I have seen some of these post-installation inspections come back that if there was not something corrected, there could have been a safety issue very quickly down the road, or at least an unexpected failure. So I think it is important. It's a good safety issue to consider, and so we support that. Now let's talk a little bit about when you should inspect. Obviously, during the delivery and storage and handling aspect of the job, you need to take care of there. I can't go into great gory detail there, but we do have some good tools on our website to help inspectors, installers, whatever you want to say, understand how to properly handle, how to properly offload our products. I think that's important. During installation, obviously, we talked about that this morning at great length about proper installation techniques. So obviously those need to be followed. I won't go into gory detail about those issues either because we covered them mostly this morning. I suspect most of you were there. We will touch on that a little bit just to drive home a few points. And I would say this, I do think, and I put the note up here, 99% rule. I think a lot of the damage that happens to all storm piping that inspectors see at the end and when they do their video inspections, I think a lot of that damage happens from the time the truck leaves our yard happens in that time. So I just caution you there that that's time to take care. You know, the contractor is wanting to get product. The inspector is there to make sure everything's going well and should pay attention to what's going on. You know, we have to make sure that when we're shipping products, we use the right tie downs, we do the right things. When we're unloading products, we do the right things. A lot of different things can happen, damage the product. And, you know, until people start looking inside the pipe, they may not see some of those things. So you need to use caution there. We have some good guidelines that will help you with that on our website if you're interested to do some of that. Obviously, inspection during installation, making sure the bedding's right, the backfill's right, handling the product right, not damaging the product. You know, these are kind of the main points, main areas of installation we talked about this morning in some detail. But care should be taken. Good installation processes should be written either in your specs or guidelines to your inspectors, for contractors, guidelines to their field people. And they should kind of match, by the way, that everybody's trying to do the same thing. So it's important that we watch that there. Just a couple of things that we see. You may not have problems with these here, but we have seen it in other places. Lifting devices, either using improper lifting devices or handling product incorrectly. I've seen people take chains and run it all the way through the pipe and try to pick the pipe up. Obviously, that's not a good thing. You're going to break bells and spigots. I'm sure those kind of things don't happen. But, dragging the pipe along the ground, forklift, moving the pipe around the job site, nothing wrong with that, as long as a forklift driver don't do 60 miles an hour and try to jump around with it. But so you can damage. You've got to use some common sense there in those handling things. Don't want to handle the product too roughly. Homing the pipe together, putting the pipe together at the joint, making sure it goes together well. Should not be a crazy hard thing to do. I'm not, even though I put up here, using excavator bucket. That's pretty common to set the pipe in the ground, put the spigot in the bell, use some type of mechanical device to help the line home up a little bit. I'm not too concerned about that as long as you don't ram the end of the backhoe or track hoe against the end of the pipe and tear the bell up or the spigot up, bell up in this case. Use some kind of material, a wooden board, 4x4, something like that, to protect the pipe to help it go together. I don't have a big problem with that as long as you use common sense and don't tear the product up while you're installing it. All your joints in the maritime, is everything gasketed here? So not everything, but mostly gasketed? Not even mostly, okay. Some gasketed, okay. Really? Said an HRM. I would, the only thing I would say there is if you are using gaskets or you're using butyl mastic sealant, whatever you might be using to make your joint, use that properly. Everybody that supplies you gaskets for our product, and our suppliers as well, can probably give you some very good installation procedures of that. Same thing with butyl mastic and those kind of things. If you use any of that, I'm sure those manufacturers or your pipe supplier can help you make sure you're putting that in the right place, using it properly. Oh, yeah, Hamilton Kent's here. Yeah, Hamilton Kent's here. That's a good resource to you. Great people, and make good products. So it is important to know how to do that. Let's say you put a gasket in wrong and try to put the pipe together. You could pop a bell. It's possible. You can be putting butyl mastic in and put it in the wrong place and homing the pipe, and guess what? You put it in the wrong place and the pipe will not go together because you put it in the wrong place. So doing those things properly will help you make sure that we don't see some of those kind of problems in your post-installation inspection. And so I wanted to cover that before we got into post-installation inspection. Yes, sir. I certainly think rubber gaskets give you some resiliency in the joint and allow it to move. If you're using butyl mastic or even rubber gaskets, I don't think it's a wise thing to actually put the pipe joints where they're concrete to concrete. You need to leave a little room for some movement there. As far as with it or without it structurally, I don't think it makes much difference unless you do try to slam them right together tight. I think you can cause some issues there. They're not made, we really would just as soon not have the joint concrete to concrete. It'd be better to have a small gap, but some gap there for the pipe to have some room to move around and not stress that end of the pipe. So, any other questions about installation? I kind of went through that fast. I just want to draw that to your attention because if you don't do some of those things right, you'll see some issues with your post-installation inspection. Any questions, comments yet? All right. You guys are being mighty quiet. Is that an after lunch thing? I think that's what it is. All right. Post-installation inspection. As I stated earlier, over the last 6 or 7 years, this has become a bigger and bigger issue in the United States for sure. You'll see a map in a few moments. It's really concentrated mostly on the East Coast, so that's close to you. So it's happening very close. I know already HRM videos their lines now as part of their post-installation process. So some of these techniques are already being used here in this area. Just general comments. My personal opinion is, after studying it very hard, you're going to see some very good equipment in a few minutes that I think is very accurate, and you should be using, for sure, on small diameter pipe that you cannot have manual way access to. I certainly think any pipe that you can safely enter and look at with your own eyeballs, measure with your own hands, see what's going on with your own eyes, you're going to have a much better understanding as an engineer, and it's going to be much easier to evaluate that pipe than through camera. I'm a strong believer in videoing lines that need to be videoed, which would be smaller lines you can't get in. There's some other good tag-along tools that go along with that video equipment that will greatly help you as an engineer or as a municipality, help you evaluate what you're seeing. But running a camera through a line and visually trying to figure out what's going on just based on what the camera sees is very difficult and takes a lot of experience to understand what you're seeing. And so that's the caution I would give you about cameras and using cameras only. In the video work that's being done in the United States, a great deal of it, they are requiring some other tag-along tools to go along with the video camera, which I think make good sense and I think are very helpful in the evaluation process, and we'll look at those. So small diameter, need to look at it. The only way to look at it, the only way to see what's going on inside the pipe, the best way is to run the camera through it, CCTV camera. Larger diameter, and when I say larger, I'm going to say 48 for me. I've got where I can't turn around a 36-inch pipe. I'm getting too big. And I'm not going in anything I can't turn around in and get out. I've been in pipes before, and I've actually had somebody try to flush me out of a pipe before. Luckily, it was 48. I could run through that almost. I had to kind of stoop over it, but I could run. They didn't drown me. They tried to. Long story. I'll tell you about that offline sometime. But I'm not going anything I can't turn around. I have seen some of the videos, snakes, frogs, spiders, alligators. I'm not going in if I can't turn around and get out. So I think and what we're seeing in most specifications, they do allow manual installations or physical entry installations for 48 and larger. That's normally the size. I think you might could go down to 42 or 36, but I definitely ain't going less than 36. So you'd have to use your own guidance on that and your own specifications. But I do think there's some very good tools. And again, I think the most important thing that I hope comes across today, and we'll get there in a few minutes about evaluation, is it's one thing to see it. It's another thing to understand what you're seeing. And so I hope I can give you some good information there that will help you if you're one of the people or a producer or a contractor or a municipality that have to try to figure out what's going on, what you're seeing in the post-installation video. So for concrete pipes, which we'll focus most of our conversation there today, because I think that's what you come to hear about, several things to look at. Most of the time, the specifications I see require in their post-installation to at least address misalignment, if there is any. Look at the joints, see if there's any cracks in the pipe, evaluate those cracks. Are there other issues, structural issues that might be evident there, spalling, slabbing, those kind of things? But way by far, the most common things that I get videos and people ask me to look at and comment on and evaluate for concrete pipe. The two big issues are joint gaps and cracks in the pipe wall. That's the two things that, now, I want to clarify that. That's not to say that we have a huge problem with either one of those things, except that's what we see people asking us about in post-installation videos most of the time. I probably watch several of my states that I work in pretty consistently along the East Coast are into these tools and using camera, TV inspections and video inspections, some other stuff we're going to look at in a few minutes. I watch videos probably twice a month. And will comment on what I'm seeing and what I think the condition is and those kind of things, evaluate. So I do have some experience with this, some real no kidding watching videos. It's one, and that's another thing. Not only does it look different in the video, I can't explain to you how much fun it is to watch videos for 3 hours of concrete pipe. It's like, man, every time I get the Federal Express package and I know it's coming, I got a video coming, I hate to see that federal express packaging on my front door because I know I'm going to have to spend 3 hours trying to watch this video, and 99% of it, it looks good. And I'm hunting for this one or two little places they want me to look at, which is really hard to do. So it's not any fun, but I understand it is a process we all must go through occasionally. So we'll talk about some of that. So I do have some experience in watching the videos. I don't have videos embedded here because I'm not smart enough to do that. I'm gray-headed and old, and I haven't figured out how to embed videos yet in my PowerPoint presentations. But it's not fun to watch anyway, so I didn't put any in here. But we do have some still shots of videos that are much easier to understand and look at. Besides, we talked about cracks and joints a little bit. I'll touch on joints for a minute here in a second. But alignment, we rarely have alignment problems with concrete pipe. If you have an alignment problem, if you see a curve in a concrete pipe, most likely somebody meant for that curve to be there. Okay. Normally, they don't just willy-nilly move around. They're a very stiff product. We don't see a lot of vertical sagging normally. That's pretty rare with our product, and we certainly don't see horizontal movement because the product has enough mass, it don't move around while you're backfilling it much. So we don't have that problem very often, thank goodness. I will touch on joints for a minute, even though that we only have an hour and a few minutes. I can't go into great gory detail. Let's, for sake of argument, let's say that you're looking at a gasketed joint, okay? Any manufacturer that's providing you a gasketed joint should be able, themselves and or working with their supplier, should be able to give you an acceptable leak-resistant gap tolerance for that product, okay? And I'm gonna just give you a chit-chat rule. This is a chit-chat rule. This is not the official rule from Shaw. I'm not speaking for Shaw right this minute. They, working with Hamilton Kent, and they're both here today, by the way. You could probably ask them today, they'd probably tell you. They can give you an acceptable joint tolerances for every size of pipe, and it usually does depend on pipe. It depends on their joint design and what kind of material they're using in their joint. It's pretty simple. All the concrete pipe almost that I'm familiar with that you can use gaskets with do have some tolerance. A good rule of thumb is the rule of thumb, my thumb. About an inch most of the time. Even with the gasket, you're still going to have a good seal, okay? Now, that's with a gasket, okay? If you've got a butyl-mastic joint, you certainly shouldn't be looking for a watertight joint there on a horizontal alignment using butyl-mastic. So you're looking for a soil-tight joint at best. You can probably go more than that and still have a reasonably good joint. Usually by specification, that gap is established through working with the supplier because every supplier has a different joint gap. Tolerance. It's very hard for a city or municipality or a DOT to write a joint tolerance for every pipe manufacturer because they're all a little bit different. So working with them, you can do that. Now, we'll talk about how you can really, no kidding, even better than rule of thumb, you can actually measure that gap inside of the pipe now. They do have tools that will allow us to do that. If you have a 48-inch pipe or bigger or maybe smaller than that, you can actually get in with a tape measure and measure the joint gap. Compare it against what the tolerance is. If it's okay and it's not leaking, you got a good joint. It's not crazy difficult there. So I'll skip through the rest of the conversation there, but that's the main points I wanted to make about joints and joint gaps. Again, the issue that we're continually talking about now that a lot of folks are looking at inside the pipe is hairline cracks, 1-inch cracks, what's acceptable, what's not acceptable, what if the crack's here, what if it's there. We're going to talk about those things to help you better evaluate what's going on inside the pipe when you do see a crack. I'm not going to say much about flexible pipe. The only reason I bring it up at all is they also have tools that they can remotely measure some of the conditions that you would normally find or could possibly find in post-installation inspection for flexible products. Those products, the big things you're looking for there are misalignment, buckling, bulging in the wall, deflection, wall buckling, those kind of things, which are highlighted here. Between the camera, good camera shots, as well as another tool that's called a laser deflectometer, they can actually remotely measure deflection, out of roundness, deformations and things inside of flexible pipes as well. So they also have tag-along tools that can look for these types of situations that you might see. deflection, ovality, inverse curvature that you saw in one of the pictures before. Usually, flexible products have some type of deflection criteria that decides whether that pipe should remain in place with no action, should have some remediation, or should be removed. This is kind of the typical information we see in our specifications throughout most of the United States. And I don't think it matters where you are in the world. If it's a flexible pipe, it's a flexible pipe. That's pretty good guidelines there. But they do have now ways to really measure down to a 10% of deflection. So that's getting pretty good. They're very accurate, and we'll look at those tools in the next slide or two. Inspection, post-installation inspection. The really good tools, I think, there, if you have a smaller diameter pipe especially, is the good closed-circuit TV cameras. Those cameras have greatly improved over the last 5 or 6 years. They have been used for many, many years in the sanitary sewer market. There's 4 or 5 excellent producers of product that make cameras and post-installation inspection equipment. I didn't put their names in here, didn't think that was appropriate, but if you want to know those, come by the booth. I'll share that information with you. A lot of good folks and good equipment to do that. The cameras, as far as I'm concerned, closed-circuit TV cameras for small diameter, those would be an appropriate design tool or inspection tool for any of the products you want to look at. Corrugated metal, HDPE, concrete, whatever you want to look at. I think those are reasonable tools to use. Those cameras can look at pipe down as small as 4 inches and can look at pipe, some of them, up to 120 inches in diameter. So they have a wide range of flexibility and size, and they're very good and very accurate. We also see a lot of mandrel testing required for flexible products because they're looking for that deflection. That's really the key thing they're looking for there, to see if that pipe has over-deflected past what it should. And mandrel testing, obviously, that would be a reasonable test to run on flexible products if you don't want to run the laser deflectometer that we're going to talk about. So that checks the shape, checks deflection. Those can be used for the flexible products. Laser deflectometer, again, you'll see the tool in a few minutes. It basically projects a laser ring on the wall of the pipe. They can use software then to calculate the exact diameter, ovality of the in-place pipe versus the perfect pipe it's supposed to be, or the nominal diameter it's supposed to be. You'll see those tools in a minute. So different pipe, different tools. Okay? That's really the point I want to make there. I think you got that one. Mandrel testing, we listed it on the slide before. I think it's an appropriate testing method for flexible products, except there's a few problems. There's a few things that you need to understand. If you pull in a mandrel or want to use a mandrel, here's the hardest thing you're going to have to do if you're a municipality, is you're going to decide what is the deflection of. Am I trying to get 95% of the nominal diameter? Am I trying to get 95% of the minimum possible diameter, considering manufacturing tolerances? Do I want to know 95% of the actual mean diameter? There's all kinds of ways to talk about inside diameter. The simplest way for Al Hogan from Tennessee, who's not very smart, is to say if it's supposed to be 24-inch ID, which is what you're hydraulically designing for, then you should be 95% or 93.5%, or 96.5% of the nominal ID that you're looking to do. But you'll hear all kinds of things talked about. That's the hardest thing to figure out. Because if you use some number that changes from job to job and manufacturer to manufacturer, that means every time a contractor wants to pull, or you want to pull as a municipality a mandrel for a different contractor, then you might have to buy a different mandrel every time, which is not very cost effective. So that's an issue. The other thing with the mandrel, you really only know what's going on at one point. If it gets stuck, you know it got stuck in that one part, that one point. Now, you can by footage on a rope decide where that is. You can kind of figure out where that is in the world. But then, so you take the mandrel back out, you turn it around the other side and start pulling it from the other direction, it gets stuck somewhere else. So what do you know between the two stuck places? Not anything. And there's no way to get to it if there's no manway access. You don't know what's going on. So that's kind of a shortfall. But it is a test I wanted to bring it up to you. It's a test that's still being used pretty consistently in a lot of DOTs in the United States, as well as some municipalities. So it is a tool that's there for you. Again, I think this is a much better tool for visually inspecting the inside of pipe. The cameras have got much better. The camera system setup you see on the left, you can see it can be elevated. Those cameras, when they're looking at a pipe product, should be generally in the middle of the pipe. I won't go into all the gory, crazy details that need to be done to do a good inspection, but that's one of the things they need to do, is that camera should be centered in the pipe. What if the camera's not centered in the pipe and you're looking around a joint? What do you think the joint's going to look like? If you pan around the joint and you got the camera set around the floor with a big pipe, it's going to look like the joint gap is going like this, because he's going to keep it the same magnification. He's going to sweep that joint. These cameras will look 360 degrees. They'll pull up to a joint, and you'll see them look down, and they'll see their toes. I call it toes. It's actually they'll see the wheels. You'll see the little rubber tires. So look down the rubber tire. Okay, I'm on the joint. They go right around the joint. And by the way, when they're inspecting, they look at every joint too. Almost, if they're any good, they do. So they're looking at every joint. They do pan and tilt and all those kind of things. Very good lighting. They are supposed to be in the middle, but I mean they can see anything. I mean, they will see anything. One of the best ways to understand this, and I'll tell you this, and I'll help Shaw do it if they want to do it one of these days, is actually go see one of these cameras in operation above ground, where you can see what they're doing. You can talk to the camera operator. You can see how much he's zooming in and those kind of things. It's very interesting to see how well and how close up to the pipe that they can get to by zooming in and things, and we'll talk more about that. But excellent tools, can see anything. They do a great job of looking inside the pipes. The laser deflectometer we talked about, here's the tool for that. The lower left-hand picture you see there is the way this operates. You see the sled up in the top left. Most of these are run the camera through with all the lights on, like you're normally used to seeing. They run the camera through with the lights on and looking for everything. They get to the end of the line. They turn the lights off of the camera. They hook that sled up there onto it on the left-hand top corner picture. That's got a laser in it, and it projects. They turn the lights off and start pulling it back with the camera on but no lights on. And it's projecting a laser ring on the wall of the pipe, whatever kind of pipe's there. In the lower left-hand picture, that red circle is the actual shape of that pipe they're looking at, pulling it back. Then they can take that image into their software and actually tell you exactly what the diameters are or / deflection is at any given point in that pipeline. Very nice tool to have if you're looking at those flexible products that are too small to get into to measure. So good tool. Different lasers, different manufacturers, their lasers look a little different, but they all do about the same thing. There are some cameras that are a one-pass where they do their laser and their video work at the same time. That's kind of handy. It costs more. Gee whiz, I bet you couldn't figure that one out. But most of them are a two-pass system. But two-pass takes longer. One-pass doesn't take as long. So, there's some swap out there in equipment. But they both do the exact same things. One of them is one-pass and others are two. Now, for measuring other defects or conditions, joint gaps, cracks, tears, other issues that you might want to look at inside a pipe, how big the bug is on the side of the wall, or whatever you want to look at, really, you can look at inside the pipe and measure accurately with the video micrometers. And the way that works, upper left-hand picture again, you see that's the top view of a camera. You've seen that on the tractor a few minutes ago. That's the camera head. And just on the top side, there's two little red dots. Those are two lasers. And they project two laser points onto the surface near where they want to measure anything. Okay? They do a little quick calibration, and they can actually, based on that, those two dots are perfectly set distance apart. They're usually like 2.5 inches. So they calibrate to that with their picture setting still, the camera setting still. Then they can actually, real time, setting right there, if you want to look over their shoulder in their truck, they can tell you exactly how wide a crack is. They can tell you how wide a joint gap is. So they can really see a lot of stuff. And they do that by zooming in on it, to really close. So they can really clearly see the edge of the crack. They have to make sure that they do zoom in so they can see the edge of the crack, and they're not just looking at a shadow. And they also have to be centered right over whatever, whether it be a crack or a joint gap or a tear or whatever. They have to be centered right over. So there is some operator training that needs to be done when they use these kind of tools. But they can be very accurate. if you read the manufacturing literature, they'll tell you that they're accurate to plus or minus a hundredth of an inch. Oh, John, what do I do with that? I got it somewhere. It's in my pocket somewhere. It's so little I can't find it. They will actually say they're plus or minus a hundredth of an inch, which is pretty small if you do a little calculation. That's tiny. I got it. No, I just can't find it. It's in here somewhere. I've got a hundredth of an inch joint gap gauge here. I want to pass around. I'll start passing around if I can ever get it. There it is. John, would you pass that around for me? That's a hundredth of an inch, by the way. You can't even see it from where you're sitting, probably, but we'll pass it around and show you. And I started that for a reason, because I'm about to get to talk about evaluation of cracks, and that's usually where we start talking is a hundredth of an inch. And I want to explain why we start talking and what that means. But this tool can actually measure, if the operator's pretty good, can actually measure cracks down to as small as that little leaf gauge that's been passed around to you. I talked about the trends in the United States. Both the tools that we just kind of reviewed, the video micrometer as well as the laser deflectometer, those are being required right now, or allowed, either required or allowed, in about 11 or 12 states, and that changes almost weekly. This map is probably a month or so old, but this is generally what's going on. The ones you see hashed, cross-hatched, those are the states, the 11 or 12 states, 13 states, whatever it is up there, that require or allow those type of technology to be used in their post-installation inspection criteria. Many of them required, a few of them allow that, or the states you see in yellow, those states require manual testing for flexible products to make sure they're not over-deflected in their post-installation inspection. So that's the difference in the colors there. So we're seeing quite the trend, and obviously you see the trend. The big trend is it's East Coast. I think the trend after that, you're going to see it moving west probably as we go. But it's really concentrated right now on the East Coast. I think we've already talked about this. I think they're very good tools. We support the use of these tools. We think it's good for all of us to know what's going on inside of products. It is a great tool to help us, if everybody's doing everything right, to help us see if there's things we can improve on, which is a good thing. They do find everything. There ain't no hiding from anything. There ain't no joking around about it. It's real life, no kidding measurements. And they're really pretty accurate. So it's not even, they're not like you can argue the technology. The technology is really good. And it's even getting better as we move along. So it's a very good product. If you're into asset management, if you're a municipality or whatever, it's a great first step. When you do that post-installation inspection, you know the day one when you accepted what you got. And you can continue to compare what you got the day you bought it to how it looks 20 years from now, 30 years from now, 50 years from now. So we think that's going to be some good information, especially for our product as folks start doing that, doing asset management and looking at their installations over time. Now, over the years, we have always chit-chatted about cracks in concrete pipe. We're going to talk about it. Y'all are probably sick of hearing about it for about 20 minutes here, or 30. But it is important to understand cracks in concrete pipe, how they're there, why they're there, what causes them, what's okay, what's not okay. Very important. I do want to say this, though, and I just challenge you to do this. There is no concrete surface in the world that I know of, hardly. I don't think you rarely find one, that you cannot find some type of crack in your sidewalk, any flat work, concrete slabs, concrete pipe, bridge beams, bridge decks, anything you want to find, they're going to have some cracks in them. Now, the issue that we always have when we start doing really good post-installation inspection, again, we support it, but we have to go in and start talking about issues and cracks again and what that means to you, what you should be worried about, not worried about. When we start doing good post-installation inspection, we usually almost without fail, every time some new standard comes out of the DOT, the first 2 or 3 jobs are just a fire drill. I mean, everybody's pointing, everybody's screaming, everybody's yelling, contractor's mad at the supplier going crazy, trying to be nice to the DOT and be nice to his customer and all those things. It really gets difficult to deal with. We're involved, engineers and other engineers are involved. You get about 10 people with 10 different ideas. So I hope this today will maybe get us on generally the same page here. I think that'll help when you do see things in your post-installation videos. Now, just a little bit concrete anatomy. Concrete, very strong in compression, weak in tension, right? We know that. We understand there's some areas of our product that will be in tension once it's loaded, and we'll look at that in a minute. Those tension areas, guess what we put in those tension areas? We put in steel. That's the reason our pipe is reinforced concrete pipe. If we didn't have any tension in the product, we wouldn't need any steel. The steel is there to control the cracks from getting too wide, okay? That's the very basics of the crack, and I think all you guys probably understand that pretty well. When the pipe's loaded, it is trying to deflect, even though concrete pipe will not deflect very much. There are zones of the pipe that go into tension. Those tension zones, once it's loaded, are the areas in red. So, where would you expect your cracks to be if you ever see a crack in a concrete pipe? What's the first place you expect to see a crack? Bottom of the pipe. Somebody said bottom of the pipe. Thank you very much. That's normally going to be the first place. Anybody got a guess on the second place you're going to see a crack? Top. Perfect. You guys are way ahead of me. All right. Now, what if you see a crack on the inside of the pipe at the spring line? It's on the inside. It's probably all the way through. Now, you said you're in trouble. We're going to talk about that. I don't think you're in trouble, but it is probably all the way through. Okay? But remember, that crack's probably not ever going to get very big because it's in compression right there. It's trying to hold itself together, the product is. So that's kind of how it's going to happen. Let me say this. I think maybe I got on the next. No, did I do? I'm trying to think if I got 3-inch bearing rack on here. I don't guess I do. I must not. Tied together pretty well what we're talking about this morning. You know, we do strength test our pipe before we ship it. We do that through the use of a 3-inch bearing rack, and there may be a picture coming up. I can't remember if I've got one on my slideshow here or not. But we load it just like the red arrows show it. 2 little hard rubber strips at the bottom and a hard rubber strip at the top, and we compress that pipe and check the strength. I would say this. Please get with Shaw sometime if you're interested. Do a plant tour. In your plant tour, see how they manufacture pipe. Look at their quality materials. Look at their quality control. And even the coolest thing to see besides a pipe stands on its own within seconds with no foam around it, which is pretty cool, by the way, if you've never seen that. It really does. It really happens if you haven't been in one. They pour it, take the jacket off, and the pipe stands there by itself. It's standing on its own. The second coolest thing besides that probably is the 3-edge bearing test. Every plant tour I've ever done, I want to get the engineer to come see that. And I want you to see it for 2 reasons. I want you to see how cracks form. I want you to see what a 100-inch crack looks like. I want you to see how much strength we have between the 0.1-inch crack, which is a test criteria, and our ultimate strength, which is another test criteria. I want you to see the difference in it, how much more load that our pipe carries once we meet that 100th-inch crack. It's important for you to understand when you're evaluating pipe that 100th-inch crack, all that means is that crack is probably, may not even be the steel, but the steel is, the crack may be the steel, and that steel is going to hold that crack from opening. If you go to the plant and see that 3-edge bearing test, as they load it, you'll see that crack continue to open up a little bit, but it carries a tremendous amount of more load once you hit 0.1 to the ultimate. 50% more load, actually. That's what it's required to carry. So it's pretty neat to see that in real life. So please come see that. It also helps you understand crack forms bottom, crack forms top, crack forms on the outside haunch. You'll see as you load it, you'll see that crack travel through the wall at the haunch. That's a cool thing to see, to understand as load is increased, how the cracks change. Pretty neat process. One of the other things that we do, if you get to do a plant tour, is maybe, as we talked about a while ago, do a demo for your post-installation inspection. Because then you can set up the pipe on the ground. We can pre-crack it. We can hold a crack open at different dimensions. You can run the cameras through it that we talked about, and you can see with how the camera sees a crack. And you can take your eyeballs in that pipe and see how your eyeballs see the crack. And where's the little leaf gauge at? Somebody got it? Little leaf gauge. You pass somebody. Oh, somebody got our leaf gauge. Where's a 100th-inch leaf? Come on now. You can't steal a leaf gauge. That thing's worth $10. There it is. So you can take that leaf gauge and see. All right, the camera sees that type of crack, and it can zoom in on that crack and make it look extremely large. But in reality, the crack's not changing. The zoom of the camera's changing. That's an important thing to understand. And you can tell when you're watching videos. You can see them zoom in, zoom out. And if you really have the full reports, you can tell what zoom amount they're at. So that's an important thing to also know. Now, so we talked about how the cracks form. How am I doing for time, Ron? I'm okay. I'm good, right? Yeah, I'm real good. All right. So let's talk about now. We talked about how the cracks form a little bit. Talked about our test crack criteria being 100th inch. And understand, that's a test criteria at the plant. It has nothing to do with the performance of the pipe in the field. Nothing. Not anything. Zero. Okay? But we do need to understand the width of the crack and maybe have some criteria there. Understand what some of the national standards say about that, because I think you could use those as a guide, and we'll talk about those. Autogenous healing, we'll talk about that issue a little bit, how that can also help you and calm your mind a little bit about cracks. Orientation, meaning is the crack a long crack down the barrel, or is it a circumferential crack around the pipe? Talk about what those two things mean and how they're different, how you should consider those a little bit different. Location, top, bottom, spring line, in between the spring line, some crazy weird place, spiraling around the pipe. I mean, I've seen enough videos now, you might see several different things, but location should play into your evaluation, so we'll talk about that, and severity. Once you know all these things, crack width, orientation, location, now I know what those are. Now, how do I know how serious that is? How do I determine if that's something that needs to be repaired, or it's okay, I can leave it alone? So you take all those first three or four things together to determine severity, decide what you want to do. So we'll give you some guidelines there. Hopefully it will help you. Now, I don't know if I've used this word or not yet, hairline crack. When you come see a pipe test at our plant, when they're testing it, you'll see a very small crack form before we get to the 1-inch crack. That crack width that's less than 1/100 of an inch is a hairline crack. Now, not only can those hairline cracks form by load, as we're loading on a 3-inch bearing, they can also form just by what we call shrinkage cracks. Most of you know a little bit about concrete. We do cure our concrete very well. We have a prescribed rate of temperature and moisture control that we have to meet to get good quality pipe, and we do that. But no matter how good you try to do that, and as best you can do, occasionally you will have some shrinkage cracks right in the surface of the concrete. That's not structural. That's not an issue. It's very shallow. It really is just on the surface. So those, you can see some of those very small hairline cracks because of shrinkage. You may see those on your job site when the pipe gets there. That does not mean there's anything wrong with the pipe. That's not a structural issue. It's, in my opinion, not even an aesthetic issue, but some people think it's an issue. So be aware of that. So hairline cracks are not a problem. Hairline crack on the job site, delivered, would be, or in the ground, would be less than 1/100 of an inch. That is a definition of hairline crack. And we've even talked a little bit about how they can form. Now, the next one that we see talked about a lot is an 0.1-inch crack. 0.01 inch is talked about a lot because our manufacturing standard and our testing standard for our 3-inch bearing, that's the crack we're looking for. All right? That has nothing to do with crack in the field. But we end up having to talk about that because that number gets thrown around a lot. 1/100 inch crack, and who's got the gauge now? Here it comes. Somebody hold that up real high again. So 75% of you, almost 80% have seen that, how wide, or not wide, I say, that 1/100 inch crack is. That is, I'm telling you, in a video inspection with no zoom, if the guy is moving his camera along at a reasonable speed, he may not even see that crack unless there's some dampness in the pipe. Dampness in the pipe, you'll see a little bit of wicking sometimes around 1/100 inch crack, and it'll look like it's a big crack. When you zoom in on it, you'll see it's not even a 1/100 inch crack. Very, very minor crack as far as I'm concerned in the field in the installed condition. Again, ASTM sets that as a test criteria at our plant. So then we have people trying to apply, municipalities, whoever, consultants that write specs, they want to apply that standard to pipe in the ground. That's not a good application. It is a testing criteria at the plant. We've had to address this for 80 years now, so we're used to talking about it. That 1/100 inch, even the test criteria is arbitrary. It really does not mean anything structural other than when they first started doing the writing standards back about 1900, the spec said when we test our pipe, they want to test our pipe for strength, you were watching for that crack, the first crack to form. Well, without my glasses, the first crack's not going to form for a long time because I can't see it. With my glasses, the first crack forms a lot faster. I can say, oh, there it is, I got it. You stop test. Well, my test today, and John can come back behind me tomorrow, run the same test on the same exact piece of pipe made the same day, and he would see the crack at a different time. That's not very consistent. That's not giving us good information. We have to have something more subjective than that. So it said, oh, the guy happened to have a leaf gauge. 100th inch. Oh, there it is. That's good. That's a kind of a small crack. That's what we're looking. We're going to start looking for that. What I would say is really the steel is picking up zero load until at least a 100th inch crack, maybe even a little past that, but at least a 100th inch crack. The steel is not catching any load until that happens. So in my opinion, 100th inch crack, nothing to do with structural condition in the field, and should not concern you. Again, we put the reinforcement in our pipe to control the crack width. That's the reason it's there. It also helps us for some strength, but mainly it's helping us with crack width. Most of our product without the steel on the 3-edge bearing rack would make the 0-1-inch crack without the steel. But what would happen as soon as we got past the 0-1-inch crack with no steel in it? Very quickly what would happen? We would have a catastrophic failure. It would bust all to pieces. With our steel, you come to their plant, and I guarantee this will happen. You take a 36-inch or pipe or bigger. I'm using that because I know this will work. You can load that pipe to 0.1, and it probably won't have a crack in it. The prescribed rate won't even have a crack in it. It'll usually go 10 to 20% past that before we even see an 0.1-inch crack. Then we test it up to ultimate. It'll usually exceed ultimate by 10 or 15%. And you can still continue to load that pipe. Now, the gauge won't measure any load, but you can still continue loading. The cracks just keep opening. It's not really taking any more load. It's just deflecting. But that pipe will never bust all to pieces and just fall apart. They can keep on hammering on it. It just won't fall to pieces. So it's a cool thing to see. Don't know what it has to do with what we're talking about today. But anyway, it is very strong. That's the reason we have steel in it. It controls the crack. The steel in small diameter pipe, which we have not very much cracking issues with anyway, that steel is right in the center of the wall usually. And we usually use a single cage up to about 24, 30, 36, something like that. And once we get 30, 36, it's usually 2 cages. And you see what 2-cage scenario looks like in the top right-hand corner. Those 2 top pictures are the more common methods of steel reinforcement placing. Other 2 would be some really weird deal. Again, we've been talking about this a long time, even back as early as the mid-1900s, and we started getting our bedding information much better and doing a lot more research. One of the pioneers in our industry, a lot of research for our pipe, made the comment that cracks up to a 1/16 of an inch will not permit corrosion except under the most adverse conditions. And that's what usually we hear from engineers or people that are looking at the pipe and trying to evaluate it. It's got a crack in it. I'm getting a little water, I'm getting some seepage through the crack, so I'm worried that steel in that crack is going to, the steel inside the pipe is going to rust. It's going to cause spalling. That would be a very rare condition for a crack. As he says, up to 1/16 of an inch, I think that's pretty safe. I don't think you're going to have any problem with that. Remember, one side of the crack is trying to open on a round product, and the other side of the crack is trying to stay shut, no matter where it is. One side's in tension, one side's in compression. Okay? So one side is squeezing down, ain't going to let nothing in. Other side is trying to open. Okay? But they're doing it at the same time. Okay? Even if somebody made the comment, if it's through the wall, you got a problem. I don't think you got a major problem just because it's through the wall. I think there's got to be something else after that would cause you to have a big concern. Even if you had to crack the top, bottom, and spring line of the pipe, if none of those cracks are 100th of an inch, you definitely don't have a problem. I don't think there's any issue there. Now, when they start getting open more, we'll talk about that. Maybe they need to consider some other things. But a 1/16 of an inch, according to Mr. Spangler, would be okay. You shouldn't be worried about corrosion in your steel, and I think that is a reasonable thing to think about. 20 minutes. I'm on 83. Oh, that's pretty good. I'm okay. I think I got a 98, so I'm getting close. AASHTO LRFD, and I didn't say this yesterday, but that stands for the American Association of State Highway Transportation Officials. Don't mean nothing to you probably, but in our world, I said that yesterday too, and I got me in trouble yesterday. In the United States, that is the group, the DOT engineers. They get together and write specifications for all products, including concrete pipe. So this is not a specification written by Al Hogan. It's not a specification written by ACPA. It's not by Shaw. It's by a group of DOT engineers that write the specification. They send it out to all the other bridge engineers in the United States and say, does this look okay? So this is what they came up with. I think it's a pretty good guideline. There may be, if you were going to write a specification for your municipality, this is a good starting point. You might want to add some detail to this. I think that would be helpful. Because they write, you've got to remember now, they're writing a specification for the entire United States. You may have something that you feel like is a little different, needs to be handled differently, whatever. So you might want to add a little more detail to yours. But this is what they say. And we're talking about crack width now still. Crack less than or equal to 1/100 of an inch, or it should be considered minor and okay. We've already went over that plenty enough. But that's even what AASHTO says. AASHTO also says a crack between 0.1 inch and 1/10 of an inch. Oh, crap. John, I ain't got a dime again. You got a dime? Anybody got a dime? I need a dime. Come on, dig for your change. I got to have 2 dimes for my presentation. These are my props. I forgot my props. I got everybody digging for dimes. I got 2 dimes. I need 2 dimes. Oh, I got one over here. Rodney's collecting dimes. I get to keep them now. I'm working for this. All right. I got 2 dimes. I think these are Canadian dimes, so I'm not sure this is a perfect example, but it's close. A dime is 0.05 inches thick. That's what it is. You all seen the leaf gauge now, it's 1/100 inch. So you stack 5 of those up, it would equal 1 dime. I'm just trying to give you perspective of what they say here. The upper end of a crack between 0.1 and 1/10 is, guess what? 2 dimes. That's where you need 2 dimes. Okay, so put that in your pocket, think about it for a minute, take it back out of your pocket tonight, think about it again. Okay? 2 dimes, 1/10 of an inch. So between a 1/100 inch and 1/10 of an inch, evaluation is required. And basically, they say, AASHTO says, and we'll make this point again, if you read all the commentary that's in that section of their specifications, they say up to 1/10 of an inch is acceptable, generally acceptable. They go on to talk about corrosive environment. Their talk about corrosive environment is centered around pH for the most part. And if the pH, in their opinion, is greater than 5.5 or greater, you don't have a problem even with a crack up to 1/10 of an inch. Structurally, I would agree with them. And I think the pH is a reasonable thing to look at for corrosive conditions. There may be other things you want to consider. If it is corrosive, then it would be considered, in their opinion, detrimental, and that crack should be sealed. Okay? That can be sealed with a chemical grout. It's what we see most of the time. If it's a large enough pipe, you can actually get in and hand repair the cracks. But let me tell you, you cannot get grout in you can't get cementitious grout in a crack that's 1/100 of an inch. It's impossible. There's not enough room there to do it. So 1/100 inch, 1/10 of an inch is okay as long as it's not bad pH. That's what AASHTO says. I think that's a good starting point. Crack equal to or greater than 2 dimes. Okay? So now they're thinking, we really need to check, see if it's a structural issue. If it's not a structural issue, and we'll talk about how I think what they mean. They don't really go into great detail in their explanation. But if it's a structural issue, it needs to be repaired or fixed. If structurally repaired, if it's not a structural issue, it can be just sealed, simply sealed to keep water, material from moving in and out, which could cut down on your lifespan of the product. So if it's not repairable, it can be remediated or replaced. That's the AASHTO guidelines. That's not mine. Now, on small cracks, we have research, several pieces of research that's been done on autogenous healing. You can see this if you go out to the plant too. If you see a pipe's been on your yard for a while with a little small crack in it, you'll see this phenomenon happening. Free lime in our product will react with moisture, and you'll see crystals start forming inside of the crack. The crack will fill up, and that autogenous healing is a very strong process. In fact, you can take that pipe and put it in 3-inch bearing rack, and it may crack somewhere else, even not there. it'll crack somewhere else first. So it really is a real thing. It really does happen. I think there's a limit to how big of a crack that will happen in. Obviously, if it's a big crack, it may not ever happen because it doesn't have the two sides of the concrete to bond to and the crystals to form in. I think, again, I've seen research that shows it happening greater than a tenth of an inch, but tenth of an inch is probably a good thing to think about there for that kind of thing to happen. And I think it's a real issue that you ought to consider. We do have some research. I'll flip through that, but I can hand it to you later if you want it. Orientation of cracks. Long cracks. Down the barrel of the pipe. Those are normally loading cracks. Doesn't mean they're overloaded. It just means it's caused by loading. Circumferential cracks are the ones that run around the barrel of the pipe, and we'll talk about those a little bit. Again, this is kind of that's a fairly significant longitudinal crack there. I don't know what the width is. I don't remember what the measurement was. Again, AASHTO says for those long cracks, they really talk a lot about the longitudinal cracks because they understand those are the cracks that are loading cracks and need to be considered as far as evaluating more stringently. If they're wider than a tenth, as we already said, they ask them to be evaluated even up to wider than a hundredth. If they're acceptable even up to a tenth of an inch, as we already talked about. Longitudinal cracks here, again, same thing I said. I'm getting ahead of myself by a slide or two. Circumferential cracks, or transverse cracks, as they're called in the AASHTO documents. They shall be monitored, and that's all they say. And I'll tell you the reason I think they say that. Those cracks are not a structural issue for us, for our product at all. And I'll tell you again, this is something else to watch if you go to the pipe plant. Look at the steel cages we produce. The steel cage is inside of a concrete pipe. There is steel that runs circumferentially around the barrel of the pipe, and there's steel that runs longitudinally, the blue lines you see here. Those blue lines, those longitudinal steel, that's only there to hold the circumferential steel in the right place. The circumferential steel you see in red is our structural component of the steel cage. So if you get a circumferential crack, which steel is that crack cutting across? It's cutting across the longitudinals. They're only there for holding space. We don't care if every one of those rust in two. We don't care. We don't care if they break. It don't make any difference from the structural standpoint of the wall of that pipe. Okay? Now, circumferential crack, if you have some offset in it, or it can get very wide, then you consider it as a joint. It needs to be sealed in some way to keep material from moving in the pipe. That's about the best way I can put it. From a structural standpoint, they're not a big issue. Now, we've talked about this already, so I'll skip over it pretty fast. Invert and obvert cracks, small cracks, what? Those are normal. You should expect to see those occasionally. They're not an issue. Spring line, again, you know that those cracks are probably through the wall, but remember, inside's trying to squeeze together, so they're probably never going to get very big, especially if you don't see any spalling. They're not a serious consideration, but you know the pipe's under a pretty considerable load, maybe even more load than it was designed for. So first thing I go look at is design if I had those. But I don't know, even then, I still think you could apply some of the width criteria we're going to talk about to whether they should be repaired or not. In the haunch, now when I say in the haunch, I mean between the invert of the pipe and the spring line. If you get cracks over in these quarter points, really watch those because they could be a minor crack, but there are occasions when those are a first indication of a process we call, dadgummit, can't get the word out. Excuse me? Radial tension. I couldn't get the word out. Radial tension shear. And what's happening there is that the pipe is trying to deflect. It's got a serious load on it. The pipe's trying to deflect. In fact, the pipe's under such load that the steel that's supposed to be round cage, is trying to straighten out and flatten out. So when it tries to flatten out, it starts cracking along one of those long bars. It'll follow that long bar, and then that steel starts trying to straighten up, and it'll pop off a large section of concrete, which we call a slab of concrete, slabbing. And so that if you see those cracks in those haunch areas, really pay attention to those. Are they wide, or do they have some offset? If they're not wide, don't have any offsets, you probably don't have radial tension. It just happens to be a small crack following a longitudinal wire, which is not an issue if it's not very wide. But be careful, make sure there's no vertical offset on those, because if it is vertically offset, you could be dealing with some pretty serious shear in the wall. Severity, again, we talked about width. I think that's your first criteria to start with, is width of crack. We Talked about location. That's another good telling sign. Is there displacement across the crack? If not, you're probably okay as long as it's not too wide. Is there signs of radial tension shear that we just talked about? That would be an issue. Here's the point I want to get across. Hairline cracks. Please don't cause fire drills for hairline cracks because it's not necessary. A crack less than 1/2 inch. Design cracks. Cracks up to 1/100 inch. Again, shouldn't be no fire drill necessary for that. Cracks up to 1/10 inch. I would start looking at, am I in an encroachment environment? If I'm not too worried about it. If you have some leakage you want to deal with, seal them. But I wouldn't worry about it too much till I got up close to 1/100 inch or somewhere above a dime width at least, okay? Consider autogenous healing in those small cracks. I think you'll see that forming in a very short period of time. Ash toe is a good place to start from. Understand the video technology makes cracks look bigger than they really are. If all you're using is video, you need to be really sharp in understanding how to understand what you're seeing. If you really want to be good, if you want to look at the pipe and really be a stringent inspection, get those tools that measure those crack widths in a smaller diameter. In the large diameter, go in and measure them and use the criteria that we talked about today, hopefully, or something very close to that. It'd be nice for all the players, all the stakeholders, from the owner to the producer to the installer, to have nice, clear, written direction of what's going to happen if we see this is what the action we're going to take. Then everybody knows what they're into. But I also think if you do that, it needs to be reasonable. It's not to the city's advantage, the user's advantage, or anybody else's advantage to repair things that don't need to be repaired. You're spending money that does not need to be spent. Now, it's also just as bad, though, not to fix something that really needs to be fixed. So, but you want to be reasonable with your repair criteria. I'm good, right? I got time? Okay. How many was here this morning in our presentation? Oh, excellent. So 99% of you were here. Good. So y'all got this. We've seen this before. This is the design we did this morning. Anybody remember what class of pipe this example called for with a type 2 bedding? Anybody remember what the class of pipe was? It was a class 3. All right, we also ran the design using a type 3 bedding, correct? What was the class of pipe required there? It was a 3, but it was what? It was right on the edge of a 4. It was right on the line between 3 and 4. Depends on who you are. I would call it a 4, but by math it was 3. But we all agreed that it'd probably be better to have a class 4 there. So this condition here would call for class 3 or 4 pipe. Okay? We know that this particular job was installed with class 3 pipe. All right? Now, let's look at a few pictures. These are not still shots from a video camera. I'm sure these are just still digital images, I guess. But this is kind of what you see if you were looking at it through the camera. I wish we had one that was really looking at it through a video camera because it really is significantly different looking. Here's a real shot, the real digital camera shot. There's a picture of a section. This is in the invert. I know it's an invert because there's water there. Okay. Another shot of the invert. Little crack there down the invert. Here's a picture of the bedding and backfill. Not totally, but you can see the Class A or Type 1 crushed stone material fully embedded around the pipe, it appears. You see rubble stone, shot rock. That's what I call it, shot rock. Backfill above that. I assume that was all the way up to grade. Remember, this is 12 foot deep. Well, would you expect to see those kind of cracks? I wouldn't have if I hadn't done a little studying, and I didn't do the math. And when we did the math this morning, maybe call for it could be needing a class 4 here. We talked a lot about it this morning in our installation issues. There may be another way to do it besides going class 4. But let's stick to the evaluation for a minute. We'll get back to that. All right, so now we went through how to evaluate cracks. Now, I would tell you this. I'll give you this hint. That pipe was 48 inch, so we could walk inside of it, right? We walked inside of it. Who's got the 100th inch gauge? You got the 100th inch gauge, right? Hold it up again. You got it? 100th inch gauge. There it is right there. That would not go in that crack you saw, which means It was less than a 100-inch crack. All right, so what should we do with that crack? I heard the right answer. Somebody said it louder, though. Not a thing. There's not a thing to do with it. It's not a problem. All right? And I doubt that, it probably wasn't quite that easy. Now, I don't know that we repaired anything, but I bet it wasn't quite that easy in real life. So it's less than a 100th. Even if it had been more than a 100th, up to 10th, I would say if the pH is okay, if there's no other issue that concerns me, no offset in that crack, I would have still said it was okay. Worst case, up to a dime or bigger, if it's a dime or bigger, you might want to seal the crack, but I'm not even sure that's necessary. I personally don't think it is. The crack location, would that be expected? Yes. That's the first place you're going to see a crack, top and bottom, so it's not like I'm freaking out that, oh my God, it's in the haunch and it's got a big offset or anything. So expected location. And the next thing that always happens if you do this evaluation is somebody wants to know why did it happen at all. One, remember, concrete cracks. Okay, so we got that out of the way. But now, why else would it happen? All right. We talked a lot about this morning that maybe the bedding's a little hard. Maybe that combined with heavy compaction above the top of the pipe is stressing the pipe wall. I don't know. That's my guess. That's what's happening. We also know that this pipe, we took a pipe off the job site that was not cracked, that was not in the ground, took it back to the plant and did a 3-edge bearing test, and it tested to, guess what, a Class 4. It's only required to be a Class 3, but the strength we have is a Class 4. So even in this case, if we'd used the Class 4, we might have still got those cracks. It's very possible. All right. So we talked about some of the ways to maybe help that, keep that from happening. Not compacting under the pipe, being careful compacting above the pipe. Maybe I've talked about 10 people. I've got clear stone running out my ears, I think. We've talked about all kinds of different things. I talked about 3 people, and I'm trying to get a better grasp on what happens here. So I've got a little more, it's hard for me to get right down to what y'all do. I need to hang around with you for a few weeks. I know that we're rocky here and we got clay other places, and maybe I'm emphasizing this too much, but as I was driving around the little area I've been driving around, it looked like you were mighty rocky here. I come from a place that we can't get fence posts in either without hitting a rock. So I'm very familiar with this condition, at least, that you have here right in this location. But, I think there's some things that could be corrected to keep some of those things from down. If you don't change anything, then you need to expect to see some small cracks. Not that that's a big problem, but you need to expect to see it. Now, normally, and I'll let John answer this from a local standpoint. Normally, 3 or 4 days we get strength. We get our 28-day strength fast. We can 3-edge bury test a pipe usually in 3 or 4 days. And if the strength's there, the strength's there, and it usually is. We really ramp up those concrete strengths to get that strength fast. Now, it's not to say there's never has been a green pipe shipped, but that's not ready to be shipped yet. But that's definitely not commonly done for sure. John, you want to handle that one too? It would be nice to have from time of pour to time of install 7 days, and that's not many times we beat that. We can beat it, but not many times it happens faster than that. But it can, we ship pipe 3 or 4 days sometimes, I'm sure. And we don't ship it though unless we prove that lot has met strength. We wouldn't ship it unless we prove it. Other questions about inspection? Yes, sir. Mm-hmm. No, it's a little different. The only difference between a Class 4 and a Class 3 pipe is the amount of steel. We will not see, the concrete strength's usually the same between 3 and 4. We do ramp up the concrete strength when we get up to Class 5, usually. But, the test criteria for a Class 4 is different than it is for a Class 3. We have to put more load on a Class 4 before we see an 0.1-inch crack. So usually we don't see a hairline crack until later, and we see the 0.1-inch crack usually, well, we wouldn't ship unless it happened after the required strength. So a Class 4 pipe is a little bit stronger. Just so happens on this pipe that we took back from this specific example, it strength tested, even though it didn't have the steel in it for a Class 4, it's strength tested on a 3-edge bearing rack to a Class 4. The reason that happens is we're getting 28-day strength in a few days. We get way more than 28-day strength in 28 days. So our pipe is always going to break more than it has to, especially as we get out into time. So it's continuing to gain strength even well after we ship it, but we've got the strength we have to, whoever asked the question, before we ship it. So, yes, sir. You know, that is a condition that I would not be worried about. Ours, concrete's also, not only is it crack, it's porous. I would not be worried to see a little dampness on the pipe. Doesn't concern me at all. Now, if it's a, well, I'm trying to think what they call it in NASHTO terminology, the inspection terminology. I want to call it a leaker, but that's not the right word. If you see water squirting through it, obviously you got a hole in the pipe. But normally, a little bit of dampness would not concern me. I don't think there's anything to worry about there. Normally, you will not see autogenous healing until a month or two at least after it's installed, because that process does not happen instantly. I mean, it doesn't just all of a sudden pop out there, but it will slowly build up inside the crack. It starts in the bottom of the crack, and it builds from the inside out. But you will start seeing that white effervescence. That is a sign that autogenous healing has taken place. Now, hairline cracks will probably never, little bitty cracks, they might not even be getting any moisture from the outside or very little. They might even get enough moisture to do autogenous healing. I could care less if they do. I mean, I don't think it matters, a hairline crack. Amen, brother. I don't know if you heard the question. What does it matter if the storm drain has a small crack? He said, does it matter? I said, absolutely not. You got to be able to evaluate structural versus aesthetic or not an issue. Whether it's storm or sanitary, I'm joking around with you. But I would agree, I don't think storm is quite as serious as... I certainly don't think storm damage, if we had a little leakage in a small crack, that should be a big concern. Very small leakage in a very small crack should not be a concern. Excuse me? Right. So what? But, you've got to be able to determine structural versus non-structural, and I tried to do the best I could to help you get to that spot today. And not me. I mean, I kind of want to point you toward ASHTOs. I think that's a great place to start and be thinking about. I didn't make that up. That's the reason I say that, because I don't want you to think I'm standing up here being self-serving. I'm not. I want you to follow ASHTO standards or something similar to that. Questions? Yes, sir. You go straight from the machine into the curing section. And it cures overnight. I don't know how many hours, but 8, 10, 12 hours, something like that. And then they come in early in the morning, tip that pipe out of the curing area, and put it on the yard. But it cures overnight. Well, yeah, I guess you call it slip form. You need to come to the plant and see one. It's called dry cast method. It is vibration and pressure. It has one form and then a tube that comes to the middle to pack it against the outside wall. There's several different manufacturing processes. You guys have 2 at the plant, or just one? You have one for pipe, right? But you can also see wet cast, which is their other process they do for storm drainage products as well. So go to the plant and see it. It's a pretty neat process. Very dry mix. Golly, what's doing that? You turn me up? You telling me to shut up? I know. Anyway, yeah, I'll shut up. I got to go because it is time for the next speaker. So if you need to ask any other questions, I'll be around in the hall or down in my booth, so come talk to me. That goes to that gentleman right there in the white shirt.